So one of the last ideas for Section 1.1 is to take a look at a couple of relatively important formulas. They come up quite a bit, and again, as formulas, they will build more math ideas, not only in this class, but in future classes, like all formulas kind of do. So the first one is a midpoint formula. So let's make sure we understand what we're looking for, right? Usually what I have are 2 points. So for my demonstration, I've got 1, 1, and 5, 3 as my data points. And what we're basically trying to look for, right, is somewhere right in here, there's a point that serves as the midpoint. All right, it's essentially, if we think in terms of distance like we're going to do in a moment, right, if we drew a line segment that goes right from one to the other, right, we're trying to basically find that nice halfway point. So the distance from over here will equal the distance that's over there, and therefore I have a midpoint. So that is effectively what a midpoint essentially is. All right, and so what we basically do, since there's basically an ordered pair here, right, x comma, how about I call it x bar and y bar, all right, to distinguish it from any other x, y. So to find my x bar and my y bar, right, it turns out that we could do is look at them one at a time. So let's look at the x-axis, right? If we look on the x-axis, we're at 1 and we're at 5, right? And I think we can visually see, right, that x bar would have to be right here, right, at 3. Okay, so how do we find that using a formula? Well, essentially, all it is an average of my x values. And so to find any average, right, we're going to take the x values that I have, 5 and 1, we're going to add them up and then divide by the number of items we're adding, which is 2. So we get 6 over 2 and we get 3. This works for anywhere you are, not these nice easy points. So to find x bar, we just basically take we sum up my x coordinates and we divide them by 2. And so right now we know that that point is sitting at 3 comma something else. Alrighty, so that is how you find the x coordinate of your midpoint. Simply average the two x values that you have. And again, that's what it means formula-wise. We're adding. What about the y? Well, same thing, right? For this line segment, it starts at 1 along the y-axis and moves up to 3. So I think visually we can kind of see that y bar is equal to 2, right? Just visually. But not everything's going to be this easy. So what's the formula? Same as this one, right? We basically take my 2 y values that I got and find their average. So 3 plus 1 is 4, divide by 2, and we get our 2 that we can visually see. So the formula for y bar, right, is your y1 plus your y2 all divided by 2. So putting this together, our midpoint formula for any 2 points, right, it's an ordered pair, remember, so I'm going to put it in ordered pair form. Your x bar and your y bar, well, this is x1 plus x2 over 2, and this is y1 plus y2 over 2. All right, and that is basically our midpoint formula. How do I find the middle of the line segment between 2 points? Well, that's how you do it. You just average your x values, you average your y values, and you're all finished. All right, so distance is another story, right? We now know how to find the middle of that line segment, but how do I actually find the distance, right, of that line segment? How do I go about doing that? So what we're going to actually do here is use a kind of a slope concept, but be aware we're not finding slope, although we could. What I am going to do, though, is use the idea when we are finding slope, we tend to run and we tend to rise. What's important for us here is that I have built a right triangle. So that's where I'm really driving at. And so basically, right, the distance that I'm looking for, let me call it capital D, right? If I can figure out what this distance is, right, let me call it, you know, I don't want to call it x bar. How about we call it dx? And if I can find the distance along the y-axis, right, so find that distance upwards for y, find this distance with respect to x, what I have is the good old-fashioned Pythagorean theorem in my way. So I'll just take my distance along x plus my distance along y, and that should equal my total distance that I have all together squared. So there's basically the brunt, kind of the background. The Pythagorean theorem is actually going to help us find this distance. So how do we find that distance? Well, again, if we look along this x-axis here, we're from 1 to 5, and I could literally just count it, right? It's 1, 2, 3, 4. So for my example, it's 4 units away. Of course, to build a formula like I want, right, what we're basically doing is taking my biggest x value, if you will, and taking away my other x value, getting 4. Right? And to get more advanced, we're basically taking x2 minus x1. Right? And that's basically going to be my dx distance. So this is x2 minus x1. In our case, right now, x2 is 5, x1 is 1, 5 minus 1. But for any other ordered pairs, that's how you find your distance. If that sounds and feels a little bit like slope, that's because that's what it is, right? Y2 minus y1 over x2 minus x1. But we're not finding slope, right? I just need to know how far is this distance on that part of my rectangle, excuse me, my triangle. So what about dy? Same thing. If we go to the y-axis, we're at 3 and 1, so we can just visually count it, right? We can see that dy is basically equal to 2, right? Of course, using the numbers, that's the same thing as saying 3 minus 1 is 2, top minus bottom. But for here, what we have, right, is y2 minus y1, and that's going to be our dy, and there's our formula. So now that I have my distance of y as a formula, I have my distance in terms of x as a formula, I can come over here and write out my formula. So d squared, right, is basically x2 minus x1 squared plus y2 minus y1 squared. All right, and if you want, if I took a square root of both sides, right, this is the way you'll probably see it as well. I actually don't care, right? I think there's two ways to write the distance formula, right? One in terms of d squared, just matching our Pythagorean theorem, or the other one where we square root both sides. You're eventually going to have to square root both sides anyways, but that's basically our formula. So, for example, if my ordered pair were going from 1, 1 to 5, 3, right? Here's my x1 and y1. Here's my x2 and y2. So what's the distance between these two ordered pairs? Well, I just plug it into the formula. I'll go ahead and use this one. So my distance, right, is my x2 minus my x1 squared plus my y2 minus my y1 squared, and we take the square root. And so this gives us, I think this is 4 squared plus 2 squared, and I think that's 16 plus 4. Right now what we get is d is equal to the square root of 20. Of course, from our review, 20 is 4 times 5. So simplifying this answer, it's 2 square roots of 5. So this distance between these 2 points is 2 square roots of 5. So that basically then kind of summarized, we have 2 things we can do between 2 points on a plane. We can find where the middle is, right, the middle of the line segment, and we can find the distance of that line segment. All right, so we either have the midpoint formula to find the midpoint, or we've got our distance formula to find the distance. So there they are. Please try to commit them to memory, because there's actually a lot of things that we build on later on in our course. And if you just remember what they are, you can hang on for the ride. All right? How about I cut this out? We're at almost 9 minutes, and I'll go do some homework problems where we just use the formulas.